Greetings. This is part 2 in my Argo CD and OpenShift Templates video series. Today's topic is deploying Helm charts with Argo CD. The application I'm going to deploy today is called Kafka Sizing. Enterprises planning to use Red Hat streams for Apache Kafka want to get an idea as to how many subscription calls they need to purchase. Nothing beats simulating the workload in your hardware, but this is not always feasible. The next best thing is to develop an analytical model to do the estimation, and Kafka Sizing is based on an analytical model. You can find the source code and a description of how to use it in my GitHub repository. Its container image can be found at quay.io. This application requires a MySQL database to persist user sessions and parameters entered for sizing purposes, and that's why I show you how to use OpenShift Templates to generate the manifest for database deployment. To deploy my Kafka Sizing application using Argo CD, you must have the following. I'm not going to read every one of them out. I just want to mention that you may want to fork my repository in here so that after you deploy the application using Argo CD, you may change some of the attributes like number of replicas and other information, and see how Argo CD responds. Now let us recap on how Helm works. You use Helm to install charts or packages. Each chart contains a collection of YAML files with template directives. When you install a Helm chart, it dynamically renders these YAML files containing template directives to generate Kubernetes manifest based on values provided by you in values.yaml files. It creates a new release for each installation. This is my Helm chart organization. I'm using a parent Helm chart with 2 child Helm charts. The parent Helm chart is called Helm Kafka Sizing. The first child chart is called Kafka Sizing, which contains the YAMLs for deploying the Kafka Sizing application. These YAMLs contains template directives so that you can change their values using values.yaml files. The second child chart is called MySQL. It contains the MySQL YAML that was generated using OpenShift Template. And the lifecycle hook to install the database schema is done by using a named template called MySQL hook. It also contains a template directive in there so that if you like, you can actually change the schema that you want Helm to initialize the database with. You will notice that each of the child chart contains a values.yaml file. Right? You can think of them as providing default values for your manifests, but you can always override those values from your parents by using your parents' value files. For example, have a different values file for the development environment and also for the production environment. Let's look at the content of some of the files in the Helm Kafka Sizing folder. As I mentioned earlier, the Helm Kafka Sizing is the parent Helm chart. Here is chart.yaml. I specify that this parent chart is dependent on 2 child Helm charts, Kafka Sizing and MySQL. The dependencies section also defines where these child Helm charts are located. Next, I'm going to show you the deployment YAML in the template directory of the child chart called Kafka Sizing. Let's have a look. All the template directives start and stop with curly braces. In here, I'm using the values object with attribute, app name, and so on and so forth. The values object provides access to values passed into the chart from your values YAML file here. For example, app name in here will be replaced by Kafka Sizing, and replicas here will be replaced by 1, and so on and so forth. Now let us look at the MySQL YAML file in the template directories of the MySQL child chart. This YAML file was actually generated using the MySQL persistence OpenShift template in part 1. It consists of a secret, a service, a persistent volume claim, and a deployment config. The thing to notice is this: I'm using an include directive to include a block of YAML from a named template file called MySQL hook. And I instructed Helm to indent the block of code by 6 spaces. Why 6 spaces? Because if you want to put it in this position, there are 1, 2, and 3 indentations, and each indentation consists of 2 spaces, and that's why it's indent 6. So what is this MySQL hook name template? Remember that in using deployment config, we can add lifecycle hooks. And this is the lifecycle hook for initializing the MySQL database with a schema. Notice that I'm using a values object here for the attribute schema URL, meaning that you can override the URL so that Helm will initialize any schema that you want to specify. And this is its values.yaml file. You will notice that each child chart has its own values.yaml file. Think of them as default values for your deployment. You can always override these defaults by using values file in the parent chart. For example, the values for production in the parent chart is saying that for the Kafka sizing child chart, I want to use these values for replica, database, root password, etc. And for the MySQL child chart, I want to use SSP for the database password, and so on and so forth. Now we are ready for a demo on using Helm charts to deploy our application. Now I'm going to show you how to deploy my Kafka sizing application using Helm only, that is without using Argo CD. First of all, I have to change the namespace I'm going to deploy my application in. For demonstration, let's go to the namespace Helm test. And then I have to make sure that I'm in the correct directory. I'm in the simple Argo example Helm Kafka sizing directory. Then I'm going to enter Helm install and give it a name. Just call it Helm Kafka sizing, and from the current directory. And I'm going to apply the values file called values-dev that is in the development environment. So let me just hit enter. Or you can see right away the ports are coming up, and running. Right, everything is running now. So what I can do now is go to the networking roots. This is the root to access the Kafka sizing application. So you need to append size at the end. And this is the Kafka sizing application running. You can play around with it and see how it goes. And that's how I deploy the application using Helm only. Now, if you want to uninstall, all you need to do is just type Helm uninstall, give it the same name that you install it with, Helm Kafka sizing. Oh, it's gone already. Oh, yeah, it's going away. Gone, completely gone. Ports, deployment, etc. That's how you install and uninstall Helm charts. Now let me just go to the Argo CD UI. So in here, select project, OpenShift GitOps. Go to the networking routes or routes. Select the OpenShift GitOps server. Click on the route or route. So this is the Argo CD user interface. To deploy the application, I need to click on the new app. Application name, just give it a name, Helm Kafka sizing dev. Project name, default. Oh, that is from the perspective of the Argo CD, not from the perspective of the user. Sync policy, automatic, prune resources, and self-heal. For source repository URL, that's just point to my GitHub example. Revision is from the main branch. Path, so that it lists a number of paths. What I want to use is the Helm Kafka sizing using Helm. Destination, the current Kubernetes cluster, which is an OpenShift cluster. The namespace I want to deploy it in, Kafka sizing dev. The value files to use, it gives you a choice. So what I want to do is the Kafka sizing chart from the parent chart, values dash dev YAML. And that's it. Just click on create. So you click on the application to get the details. Now it's deploying your application together with the MySQL database. You can see that one application, the Kafka sizing application, has a green heart. That means it's all good and running. The second replica also comes up, and so does the MySQL database. Now, let us go back to the OpenShift console. Now change to Kafka sizing dev. Click on the root or route. Append the size at the end. And now you can access your Kafka sizing application. Now let us get back to this thing here. So I show you like different ways to deploying the Kafka sizing application. Once using Helm charts only, the second time using Helm charts with Argo CD. So what are the differences? We talked about this a little bit earlier. Like we mentioned that Argo CD is a declarative continuous delivery tool for Kubernetes. It was implemented as a Kubernetes controller, meaning that it continuously monitors running applications and compares the current state with the target state. The target state meaning the state that you specify in your GitHub repository. And since we have enabled auto sync, so it detects configuration drift. That means it makes sure that the current state will match the target state. Let's give it a try. Now let me just, from the command line, let me just scale the number of pods to from 2 to a different value. Now OC scale deployment, before I do that, I need to change that project. Let me first OC project Kafka sizing depth. Then I'm going to execute the OC scale deployment command. Change the replicas count to 5 and see what happens. Now you can see that once you executed the command, the number of pods goes up, and then after a little while it goes back to 2 because the target state specified 2 replicas. It was so fast that you almost not notice it. Let's do this again, and maybe this time you pay more attention. Now I hit enter, see the number of Kafka sizing pods go up and then goes back down. So now it's coming back down after it went up. So this is the main difference because it monitors the current state and makes sure that the current state matches the target state. Right? So Helm by itself does not do that, but Argo CD does. So that's the end of part 2. Thank you for watching. Next time I'll be talking about like deploying using Kustomize and Argo CD. Until then, bye.